All right, so when we are dealing with, when we're dealing with reactions that are unfavorable, okay, thermodynamically unfavorable, what that really means is again, it's not going to happen on its own. It needs something to make it happen. And so what we can do is, as it states here, right, we can use electrons to drive that reaction forward. And so that's what we're going to talk about. So again, the reactions that we have dealt with up till now are either referred to as voltaic or galvanic reactions, right? And those are thermodynamically favorable. And so when we look at the E cell on those reactions, or the E naught, the E naught is positive, all right? Again, it has that positive voltage, which means that it's producing energy. So it's producing energy. And so obviously, if we reverse one of those reactions, right, if we reverse a reaction, it requires energy to drive the reaction. So we can use electricity to get a unthermodynamically favorable reaction to actually work. And in that case, the E naught is going to have a negative value. All right, so again, we call them non-favorable reactions, and they are referred to as electrolysis. And so when we're referring to that type of cell, that it is unfavorable, those are electrolytic cells. So here's a reaction we're going to talk about. So if we were to take some sodium chloride and we melt it, okay, and then we push electricity through that melted sodium chloride, obviously we've got to get it to a pretty hot temperature to melt it, 801 degrees Celsius. All right. Once we have molten sodium chloride, we can put in inert electrodes, and we can actually apply a voltage to our reaction, and we can get a non-spontaneous reaction to occur. So in this case, right, think about it, which electrode would be considered the anode and which electrode would be the cathode, all right? And then think about what would be the possible half reactions, okay? What would be the possible half reactions in order to get this reaction to occur? So take a moment, if you would. Figure out which is the anode, which is the cathode. You see the piece of the clue, right, is up here, right? We're showing you the direction of the electrons. So take a moment and think about, what do you think is happening in this cell? All right, so let's talk about this. Right? So thinking about reactions that potentially could have occurred. Okay? So we have sodium ions as a liquid, adding electrons to go to sodium solid. Right? We have sodium solid resulting in sodium ions and electrons there. We have chlorine ions as liquid, right? Going to chlorine gas. With electrons there, and then lastly we have chlorine gas gaining electrons to become ions, right? So those are the possibilities that you may have thought about, all right? And so again, which half reaction occurs at the anode? Hopefully you remembered, it doesn't change just because it's a electrolytic cell versus a voltaic cell. The anode is still the oxidation, okay? So remember that pure sodium metal, right, and chlorine gas cannot be the reactants, okay? They cannot be the reactants and cannot be oxidized or reduced because they're not in the container, right? They're not in the container to start, right? Initially in the container, we only have sodium ions and chloride ions. All right, so that's the only thing that's actually in the container. So, if we want to know what's happening at the anode, right? At the anode, we have chloride ions that are releasing electrons, okay? And so chlorine gas is actually going to be forming, right? It's going to be forming. And, let's see, right? Obviously, the sodium ions are going to be gaining electrons to go to sodium solid, right? So why don't you, now that we know that we have these two half reactions, put it together as it states and write the net ionic. What would be the net ionic reaction for this cell? So, right, obviously what we need to do is we need to balance for electrons to do the net ionic. So the chlorine, because we're forming chlorine gas, and chlorine gas forms in molecules of Cl2, right, we need, that releases 2 electrons. In order for this to stay balanced, right, it will require us the sodium, 2 sodiums to gain 2 electrons, become 2 sodium metal solid. So then the net ionic equation is going to be 2 sodium ions liquid, right? 2 chloride ions liquid gets us 2 sodium solid and 1 chlorine gas molecule. Again, why we state these as liquid is because there's no water present. It is just the sodium chloride, the melted sodium chloride. So it's not aqueous, it's not in a water solution, it is just liquid sodium and liquid chlorine. All right, questions on that? So, how about this? We change this up. Now we have a molten mixture of sodium chloride and potassium bromide. Okay, so it's both a mixture of potassium bromide, sodium chloride, right? What are the possible half reactions that could occur at the anode and the cathode? And we're actually going to stop there because we're short on time. So what I'm going to have you guys do is try to think about this, finish this up for tomorrow, and we'll start tomorrow right here. Okay? Thanks, guys.